Thank you for that introduction. So yeah, I've been building extensions for the last 10 years. It's a little bit of an addiction, and throughout that time, I've keep running into some friction points with extension development, and also some nasty realities about extensions that are not always obvious on the surface. So before I dive into that, I just wanted to sort of show a few extensions I've worked on as a way to show like the context that I'm working in, and also what's possible with extensions. So most of the last 10 years I spent on a project called Citus. It's sort of distributed Postgres as an extension, or transparent sharding as an extension. So you can set up a cluster of Postgres servers. You create a table, and then you call this create distributed table function, or create reference table. If you watch the keynote, a lot of these concepts have been discussed in the morning. And then those tables, they start showing up in all the nodes in the cluster, and it also creates shards, which are also Postgres tables, which contain the actual data. And if you add more nodes to the cluster, you can move those shards without downtime, because it uses logical replication. So this is useful for very large-scale operational workloads, used a lot by software as a service companies, also for kind of time series and real-time analytics workloads. And this is probably one of the most complex extensions in existence. It uses practically every hook that we could find is somehow used to create this experience, because a lot of like going from single node to distributed is actually a bit of a paradigm shift, and some things are no longer obvious of like, should you see these shards? Or like if you call a function in a query, where is that function actually supposed to run? You have to kind of come up with a lot of answers to everything, and kind of work around the regular Postgres experience sometimes. Another project I started with Vinod Sridharan at Microsoft a few years back is called PGDocumentDB. It was open sourced recently, I think MIT license. And this was basically a re-implementation of MongoDB as a Postgres extension. It's kind of an interesting extension. It's not really user-facing. It's meant to be called by a gateway that implements the MongoDB protocol. So in MongoDB, documents are following this format called BSON, a bit like JSON, but with stricter types. The queries are also BSON. The messages are BSON. Everything is BSON. And so it also has like this well-defined binary format. So the gateway pretty much just takes a bunch of bytes and gives it to a function called implemented by the extension. And so in Mongo, you don't have to create tables up front. So you can just start inserting stuff. And so the insert one function will check, oh, is there already a table? If not, I'll create a table with the BSON column and some other columns and insert the document. And then there's a few of these sort of magic functions that, for querying the table, which aren't actually functions, or they're not actually implemented. Like if the planner, we use planner hooks to sort of detect these functions, and then if we see them, we replace them with a custom scan in the extension. And then that custom scan will translate the MongoDB style BSON query into a SQL query. Can sometimes get quite complex with lateral joins. MongoDB does have a type of joins. And that query will contain BSON operators, which then use an operator class that uses a rum index. Because we needed to sort of match all the MongoDB filtering and indexing semantics, some of which are pretty crazy. So for example, if you have a unique constraint in MongoDB, and the values are arrays, like 1, 2, 3 is one array, and 3, 4, 5 is another array. In MongoDB, that's a unique constraint violation. Don't ask me why, but we managed to get that same crazy semantics from rum indexes. And then the gateway, there's a project called FerretDB, which kind of now sits on top of this extension. And then Azure Cosmos DB for MongoDB has its own gateway. So these both of these extensions are kind of built as database products, but both open source. My current project is called Crunchy Data Warehouse. And this is basically yet another attempt to turn Postgres into a data warehouse, but now purely through extensions. and also with some kind of modern techniques. So we introduced Iceberg as a storage format where you can say create table using Iceberg. Iceberg is a sort of standard way of storing tables in object stores like S3, where the data sits in Parquet files, and there's a metadata layer which describes the schema of the table, which Parquet files are currently part of the table, and some other stuff. We also cache those files on a local SSD drive, and then we sort of integrate DuckDB into the query planner to carve out a part of a query on an Iceberg table to delegate into DuckDB, because DuckDB is often like 10 to 100 times faster than Postgres for analytical queries because of its use of vectorized execution and multi-threading. Jelte will have a talk on that. We kind of stopped building super complex extensions. So we now mostly build these constellations of Postgres extensions. Part of the reason is that Postgres has a lot of foot guns for extensions, and the sort of making your extensions somewhat smaller and more modular makes it a little bit easier to recognize when you're doing something wrong. But we also then have extensions to make it easier to use lots of extensions together. And this also gives us a little bit of flexibility to say some of these are Rust, some of these are C, some of these are open source, some of these are proprietary. And I also have some ongoing open source work, like PGCron is kind of, I created that a few years back, and it's kind of become the standard Postgres job scheduler. It's in practically every managed service. It's a very simple, stable tool. It's meant to be super, super reliable. And it probably won't get a lot of new features anytime soon because it does the job it was supposed to do. More recently, we've created this extension called PG Parquet, where you can copy in the Parquet format. You can also copy to S3 or copy from a URL. You can also copy to a local file in Parquet format. Most of the work done by my colleague Ikut. And I think my most recent extension is PG Incremental. This is like a layer on top of PG cron to incrementally process append-only data. So like take all the new inserts into a table and do something with them. So a lot of extensions. Apart from building extensions, I've also been writing about extensions together with Abby, David, and Andy. Abby was here last year talking about extension compatibility. So this paper kind of surveys the database extension landscape. Turns out other databases also have extensions. I did not know that before we started. And like Abby sort of also dove into the compatibility between different extensions and appropriately called the paper Anarchy in the Database. So that's a reference to extensions. So this will be at the next VLDB. So back to basics. What is an extension? So an extension is a set of SQL objects at some version that you can sort of create and drop together. It's done by running the SQL scripts that come with the extension. There's a control file, not extremely important, but that tells Postgres that there is an extension. And then there is what is sometimes mistakenly called a module. There is nothing modular about it. I would call it a runtime patch. Because extensions are a lot more like patches than like apps. Like there's sometimes sort of attempts to create a extension app store, but to me it's a bit like creating a Postgres patch store where you kind of can pick and choose which of the latest Postgres patches on PGSQL Hackers you load into your production database. And if you think about it like that, then you start having questions of like, hey, has this patch been reviewed? How is it tested? How big is this patch? And those are the right questions to ask when looking at extensions. So extensions can add custom code in weird places. They can call any Postgres function, modify any global variable. They can conflict with each other very easily. They can crash the database. They often do. They can corrupt memory, shared memory storage. They can leak memory. They can break regular Postgres features. Very easy to have some check in a hook that doesn't actually work if the extension isn't created, and then throws error for everything that happens. The more subtle ones is that it can slow things down considerably. It's probably not enough research and testing going into this. It can also quite easily break the security model. So when you write an extension, you need very careful code review, a lot of testing, Good coding standards, try to follow like Postgres coding standards. Comments are great. And you kind of need to build up almost like committer level Postgres knowledge if you want to build like some really advanced extensions. Because I mean, it's nice with extensions that you don't get the blowback from PGSQL hackers. You can just ship your stuff. No one will stop you. But you also don't get the good feedback from PGSQL hackers that tells you, oh, this is a really bad idea. So you have to do that yourself. Now, there is a certain layering in kind of the types of extensions that we see. They're sort of the more, I would say, on the surface where, okay, we're adding functions, we're adding type, we're adding foreign data wrappers. We're kind of following the rules set by Postgres. And then there's like these more complex extensions that try to sort of bend the rules a little bit and so like introduce some more complex data-based functionality, like we can make all geospatial indexes or copy to Parquet or vector indexes. And then there's these extensions that sort of redefine what Postgres is as a time series database, a graph database, distributed database, text search database, right? And those are, of course, the hairiest where things get really nasty. But it's a bit of a scale. Like the further down you go, the more foot guns Postgres has in store for you. And sometimes I also think of them as wounds. Like you can take a few shallow wounds, that's fine. But if you take several deep cuts, you might be in trouble. Like if you combine Citus with timescale with ParadDB, you're probably Postgres is no longer going to work. So I divide it in two parts. First, I talk a bit about the trouble with extension SQL scripts, and then the trouble with extension, let's call them modules, runtime patches. So extensions have like the craziest runtime model so they get loaded into Postgres. Like your binary is usually just the latest version that was installed. And then every database can have the extension or not have the extension or be at some older version of the extension. And your extension sort of has to survive this situation because okay, maybe we should actually be updating all of these databases or run alter extension update. But at the very least, we need to make sure that the database does not crash before that happens. Because, I'm talking to you about a lot of battle scars, but you can get into these crash loops where, we cannot actually run alter extension update because the database is already down because it's taking production queries, and that crashed the database. And one of the ways in which you can pretty easily run into that is, and this is a simple example, there's a lot of other ones. So let's say you have a function in version 1 of your extension, and it had 2 arguments. And then you release version 2 of your extension, some new features, you decided, it's useful to have this extra argument in the function. And you're smart, you add a default value such that the original signature still works, so your users are happy, they can still use their scripts, and you update your C code to take the new argument, and now this code could very easily crash. Because there could be users that installed the new extension and still didn't run alter extension update, call the first function, and now this is basically like array out of bounds. We're referencing the third element of the array, which only has 2 elements. So this probably produces a segmentation fault. I often feel like segmentation fault, if you're lucky. If you're unlucky, it just has undefined behavior and can do any random thing, corrupt your contents. So there's different ways of dealing with this. We discussed some yesterday in the Extension Summit as well. Just some things we've done. So in Citus, we said, okay, this is a very complex extension. There's a lot of different ways we could get into Citus code paths. They have all sorts of expectations around which tables are around, which types the columns have, which functions there are. We don't want to have to go and deal with that. So in pretty much all Citus functions and a lot of other code paths, there's this check. It's like, is the extension updated? If not, throw an error. And so this is pretty crude because it basically means your database is down, or at least the Citus parts are not working until you're in alter extension update. But we find that this really encourages people to update. And of course, in our managed service, we update the extension automatically. Now with PGCron, that's a different type of extension. It's more of a community project. It's in lots and lots and lots of different environments. I don't know whether people update their extension, or could take months before they realize that this is a thing that they need to do. So I tried to code it everywhere to sort of take into account, oh, what if this function gets called with fewer arguments? What if this table doesn't have the columns yet? But this means that you're essentially coding against all of your past versions, which is not pleasant, and maybe also part of the reasons why I don't want to add a lot of features to PGCron, because it gets pretty tedious at some point. Other things you could do is create new C functions. I think we've done that sometimes, and you keep the old one, or you just sort of make the old one throw an error. And of course, what you really want is for all the extensions to automatically update. But even if you have a mechanism to do that, updates don't always succeed. They're just a bunch of SQL commands. They could fail. Maybe they try to create an object that already exists in the database. So it's a tricky one. So for writing scripts, there's like two high-level ways of, or writing upgrade scripts, there's two high-level approaches. One is you sort of create the first version of your extension, and then you keep adding update scripts. And then when you create extension, Postgres will just sort of replay the entire history. The downside is that you then don't have one place where you see all of your current SQL objects. There's another way where you maintain the latest version, like all of the SQL objects that you expect to have in the current version, and then write update scripts from the previous version. I'm personally always a bit scared of that approach because, I mean, it's entirely doable, but one thing that always freaks me out is, what if I make a mistake and some users end up on a different schema than others? Like, how am I going to rectify that? Like, what kind of updates do I need to do to make that work again? And that especially gets nasty if you, let's say, have two major versions that you support, and you want to patch an older major version, and it requires a SQL change. And now you have like multiple upgrade paths. Some users will go 2.0 to 3.0 straight. Postgres actually prefers the shortest path usually. Some users will go via 2.1 to 3.0, but maybe there's users on 3.0 that actually need the same patch, but then also need to make sure that I don't run alter table twice, if that was my command. So it actually gets pretty hairy to do that correctly. So I kind of avoid this like the plague. I don't want to patch SQL versions, but sometimes you really have to. Dependencies are a nice feature, a little bit broken. So extensions can depend on each other. Works well the first time, like when you do create extensions, all the dependencies are created. So actually PGDocument.db has 6 dependencies. But then alter extension update does nothing special. So if you add a new dependency later, it'll just complain and error out. Updates can fail because the dependency doesn't exist. There's no mechanism for cascading the update and then creating the extension. There's also no guarantee about which version your dependencies will be in when you update. It could be anything. So there's really a lot of possible different ways in which a set of dependent extensions might update. So that's a little bit chaotic. One more issue with the extension SQL is a little bit more subtle, but probably the most important. It's not always obvious what this commands that you put into your SQL script are going to do. Like sometimes maybe you do something like this, where you create a function in your script and then you immediately call that function because there's some initialization that you want to do that's just easier or only possible in C. But here I made a pretty crucial mistake. So I created a function with a rect class type. Very convenient actually, because with rect class, it's like a sort of simultaneously, it's a table OID, and it's also simultaneously the name of the table. So when you call something with a rect class argument, you can just enter the name of the table. And then in the C code, we immediately get the OID of the table, which is usually what we want in extensions. But when you call a function in Postgres looks at, okay, what are all the possible candidates for this function, and picks the one it likes best. And so a malicious user could create a function with the same name that has a text argument. And because this is actually a text, Postgres will prefer to call that one. So it's not going to call this one at all. And create extension usually runs as superuser. Well, there's trusted extension, but very often it runs as superuser. So then admin runs create extension. It will actually call the malicious user's init function, and they can grant themselves super user and get shell access and do whatever super users can do. And so that's a little bit of a problem. And the malicious user you have to consider is often a result of a SQL injection vulnerability in another application. And attackers can often do this like at very large scale, just find thousands of vulnerable servers, just plant some seeds, sometimes wait a few months for someone to actually create the extension. But finally, maybe you get production super user access to some production databases. So you have to be very, very careful when coding these scripts. One thing I like to do is like put stuff in an explicitly created schema. So not rely on the extension schema, but just say create schema. If someone already created that schema, that'll fail. That's fine. That's better than some random user getting super user access. Then I create functions in that schema, call functions in that schema. I know for sure no one else could have touched this. I also like to actually disable the extension schema. It's a bit more controversial, and it's also not always ideal if you're introducing operators. But like you can set the schema to PG catalog, Postgres won't complain, and basically it just means that there isn't any special schema in the search path, because extension schema is a bit of a strange feature. Extensions are database level object, but they get created in a schema. And that schema is in the search path when you execute the SQL. So this is one of the most important ones, and I also highlight this because when we were at Microsoft, we would get a lot of security reports about different extensions having these types of issues. So let's switch to more of modules. I'm mostly going to talk about C code and some of the challenges there. A very common pattern in Postgres extensions is there's some hook. In your PG init, you set the hook, and maybe there was already someone else who set the hook, so you remember that someone else set the hook. And then in your implementation, maybe you don't want to do anything. So like when you use hooks, you usually put your extension in shared preload libraries. But maybe you still don't want to do anything unless the extension already has been created. Again, you have to be very careful doing this because, well, up until recently, there was no caching for checking whether an extension exists. And there's still no caching for checking whether an extension doesn't exist. And that's actually the path where you don't want overhead. This is not a free check. And some of the hooks are really hot code paths on busy servers. So, it's not impossible to implement caching, but it's actually kind of tricky to do the invalidation properly. So it's something you have to watch out for. The other thing that happens with hooks is, okay, so someone already set the hook, so let me call that hook and then, let them figure out what to do next. And so you basically always get this chain of hooks. Now that we have more and more sophisticated extensions, they all kind of pile on top of each other. And what happens is the last one to get loaded is the first one to get called by Postgres, because that's the last one to set the actual global variable. And the overall behavior of certain bits of Postgres now depends partly also on the order of the hooks. If you change shared preload libraries order, you might actually get a different Postgres. So very recently, we get this stuff wrong sometimes. We had a crash in sort of code that was already in production. It didn't disrupt the application. It was more for a demo, but where we had a crash in PG audit, and the reason it happened was because we have an extension that sort of takes over the copy command in the process utility hook, and it doesn't call the regular Postgres process utility, but it does want to check for permissions because we don't want to introduce new vulnerabilities. But PG audit installs a hook, like a check permissions hook, and the implementation of that hook expects that its process utility function has already been called, because that's usually how it happens. First process utility, and then from process utility we call the permissions hook. But in this case, because we never called it, like the stack, the PG audit stack wasn't set up, and it sort of gets a sec fault. But it's not really obvious like whose fault this is. It's like, PG audit made reasonable assumptions about Postgres. That's actually how Postgres works. And our extension was sort of just calling this function and expecting it to work. So we have a sort of workaround for it. But like the broader point here is that extensions don't always cooperate. In fact, this goes back to Abby's paper on anarchy in the database. They don't cooperate a lot of the time, actually. So she checked like every sort of like 100 extensions or something, and ran their test while the other extension is loaded, so in pairs. And 16% of pairs actually failed their test, which is quite a lot. Sometimes it's just sort of, okay, the tests are a little bit fragile, there's an extra notice or some other change, and the test fails because the Postgres regression testing framework is kind of fragile. But sometimes it was also a pretty serious issue where now Postgres is broken or it crashes. So this is something to take into account. It probably actually requires more testing, especially on part of like managed service platforms. Now, one of the hardest things I find that I commonly end up having to do is storing metadata as an extension. So, Postgres has catalogs and stores all of its stuff. Like if you create a table, it creates records in some catalogs. And you also want to do that as an extension sometimes. Like in your SQL script, you create a table, but you don't necessarily want to give users write or even read permissions to those tables. For example, PGCron has a job table which contains which user the job should run as. If I give random users write permission into that table, they can run jobs as any user, so they probably get super user access. So now in C code, there's different ways of interacting with this table. One way is you do the same things that Postgres does when it reads from its catalog. These are low-level functions. You don't really have to worry about permissions. Like the C code can just do whatever. But there's a lot of like, you need to figure out what all these things are. Like what's a scan key? How do I lock stuff? Do I unlock stuff at the end? What is an F int HQ, BT equals strategy number? There's a lot of weird stuff here. So there's an alternative where, I can just run an internal SQL query. I know how to write SQL. But I would argue that the low-level one is the easier of the two. And it's not easy at all. So if you use these systable functions to read things or other low-level functions, you typically work, you need to know all the concepts, all the locking and what that does. You need to know. Sometimes also know about snapshots, and that if you acquired a lock, you didn't necessarily refresh your snapshot. There's some challenges there. And then you typically use OIDs. Very often you want to cache those, but caching always comes with the burden of doing cache invalidation because the extension might later get dropped and recreated, and that changes all the OIDs of the tables and the indexes. And then maybe you have different pieces of metadata in different tables, and you need to cascade, but there's no infrastructure for that in Postgres. I mean, there's PGDepend, that's what Postgres uses internally, but we cannot use that as extensions very easily. And you also have to be very careful about attribute numbers, because usually when you go down this path, you're working with the low-level tuple data structures in Postgres, and you typically address the columns by their attribute number. You can do it by name, it's a bit more expensive. But attribute numbers are not always the same for the same table. So if you followed the approach where first someone installed 1.0 and then upgraded to 2.0, let's say there was a table that first had 3 columns, we drop one of the columns, so now we have a table with 2 columns. Someone else directly installs 2.0, gets a table with 2 columns. Those are not the same. Like this table has attribute numbers 1 and 3. A fresh table has attribute numbers 1 and 2. So you could easily crash your database if you try to address attribute number, like the table by attribute number 3, or get the wrong result if you try to address it by attribute number 2. So that's one of the reasons why I personally prefer the model where everyone kind of follows the same history, even if it sort of weirdly involves creating a table and then dropping a column for a new installation. But you have to just, they're not unsolvable problems. It's just a lot of small paper cuts that you have to work your way through if you build an extension. So the other alternative is let's do something like SPI or run a SQL query. Now the thing is, I did not want to give my users read or write permission to the table. If I run a SQL query, I'm going to have to go through the permissions checks myself. That's just what the planner and executor do. So to get around those, I'll go switch to a more privileged role. But you have to be careful that when you run a SQL query, it doesn't always do what you think it will do. And there could be different types of overloading attacks. And other extensions will also get involved when you run a SQL query. And SPI, you get just planning and executing a query as part of some other operation is a slow thing to do. So you could actually, especially if this is in a hot path for an operational workload, it's best avoided. But so here's an example of how doing an internal SQL query can sort of escalate privilege. So let's say we had, this is just purely for demonstration, but like a table with some character type columns. Not many people like to use it, but it's also not entirely crazy. And then I, at some point, do some internal query on that table, and after I switch to superuser. And I just look for, select from metadata where the key equals $1. Ah, good. I used parameters instead of generating the query. Good way to avoid SQL injection in your code. The problem is this, Postgres does not have a character equals text operator. And when there is no exact match for character equals text, it will cast one of the sides to text and then use text equals text operator. But if someone else also created a character equals text operator, it will prefer to use that if it's on the search path. So then again, if we run this as superuser internally, we might actually end up granting superuser to some malicious user. So of course, there's ways around this. I'm only saying you need to be very careful. For example, in your C code, set the search path to not include anything that a user could have touched. And you also need to maybe consider what other extensions are there, what might they be doing? Do I want this to go through auto-explain, PG audit, PG-stat statement, or do I just want it to be a little bit more hidden? So that makes actually using SQL kind of hard, but sometimes, let's say you want to do an upsert, it's easier to do that in SQL than through any of the low-level C functions. Storing OIDs, also pretty hard. Sometimes you want to store information about a table or a type, that's actually okay. If you store a function ID, OID, in one of your metadata tables, you need to be aware that this is not going to survive PG upgrade. So if you want, sometimes we want to make some feature a little bit pluggable. In Citus, we had this where we wanted users to be able to define their own rebalance policy via functions. But then you probably should be storing the function name, but the function name could change. The schema of the function name, the name of the schema could change. The function might get recreated. Maybe it gets dropped, later recreated by another user. Now you're calling it with too many privileges. There's an alternative where you document that, if you want to run PG upgrade, first you need to do all these other steps. We've done that in Citus, unfortunately, but it's just not fun for users to have to do that. Many ways to get it wrong as well. One more excruciatingly hard thing is to start a background worker. And specifically to start a background worker that lives in the database where an extension has been created for as long as the extension exists. So what you want is that if Postgres restarts, all the databases that have the extension get the background worker again. But you don't know which databases have the extension without connecting to the database. So you have to go and spawn background workers for all of the databases. You're probably going to exceed max worker processes, so you have to throttle it. Then all of those databases check, does the extension exist in this database? Concurrently, someone could be dropping or creating the extension. Also, when we create the extension, okay, maybe we should start the background worker. But what if it rolls back? What happens then? Similar, the background worker will stop drop database from working. So there's always reasons why drop database fails. But so if we kill the worker and then do the drop database and it still fails, we kind of want the worker to come back because maybe the user changed their mind. So it's really, really, really hard to get a background worker that's just attached to a database and can do things like do extra statistics or some kind of compaction operations or figure out what indexes we need. So yeah, that's another fun adventure. So supporting multiple Postgres versions is usually done through a lot of these kind of if-defs in your code where this is just code from PGCron, which has been around for a while, so we still have some Postgres 9.6 code sitting there. I think recently someone asked me, can we get Postgres 9.4 support? I said no. But so this is sort of okay. Sometimes we hide it a bit behind macros. The ones that are trickier are kind of the data structure changes or subtle behavioral changes happen sometimes. One of the nastiest is actually test output changes, because then I have to go and sort of create all these alternative expected output files for my tests. And yeah, like most of the time, like for something like PGCron, which is nice and simple, many Postgres versions just sort of come by and like don't even have to change something. For Citus, it often took us like 2 or 3 months to kind of work through all of the little changes, just because it is so deep into Postgres. So there's some realities of being an extension builder where you're either probably developing a product and you're just super focused on that, and sort of doing whatever it takes, whichever hook is needed to get the customer the thing that they need, or more as a side project where you don't have a lot of time to spare on it. Now, some of these things, like we could go fix them in Postgres, but if you fix something in Postgres 19, I don't know when I'm actually going to be able to take advantage of it myself, because I'll support Postgres 16 for another few years, and sometimes like maybe using the new infrastructure just in the new for the new Postgres versions is pretty tricky. We rarely really properly consider all the other extensions that are out there. We sort of have a model of like, oh, this is how Postgres works, that's how we test. But there's also just not a lot of good testing tools for doing this sort of cross-extension testing. So these were a lot of problems. I think at this point you're tired of the problems. There's more, but any solutions? So we found it useful to sort of build a sort of foundational extensions that solve some of the extension building problems for us. So we have an extension that sort of updates dependencies before we update ourselves, for example. And we could all go and build those, but maybe there should just be a sort of central community extension that has some of this shared infrastructure for extensions that actually can get work across older Postgres versions as well, so we can all kind of benefit from it and use the same APIs. And then the core project could feed from this sort of shared extension, and it could have its own release cycle separate from Postgres itself. And it could also include more testing tools and sort of cross-extension testing tools. Some more infrastructure would be helpful. I find metadata and caching, like Postgres has a lot of its own infrastructure, a lot of it not very accessible to extensions. Hooks, function pointers are a little bit questionable as a method of extension. We had some discussion yesterday at the Extension Summit, like, okay, well, at least callbacks might be slightly better. It would also be useful to have some kind of extensible DDL, because a lot of the time we're sort of mimicking DDL by just adding functions that sound like DDL, like create distributed table. So if you'd have that and it's attached with, it comes with some like implicit metadata storage and implicit caching, you could actually build really a lot of extensions without doing a lot of more complex, sophisticated things. So in summary, extensions are hard, but they're a lot of fun. I love building extensions. So yeah, there's, well, we went through all of the problems, almost all. I think, sometimes I really want shared catalogs as well. I don't know how those would get created, but for example, in Citus we had a table of nodes, and that's just shared across all databases. But where do we store that? And better background workers would be nice, and automatic updates would be some great infrastructure. Until we get all those things, we have to sort of work our way through them. If our extension is that sophisticated that it needs to touch those things. So yeah, happy to answer any questions. We sometimes write about extension development on our blog. And you can also reach me there. But for now, thank you very much, and yeah, happy to take questions.
Thank you very much, Marco, for that very wonderful presentation. Marco is here with over 10 years of experience building extensions, and that is what he has brought here for us today. So we're going to take a few questions, and then we're going to wrap it up. Any questions?
Yeah. First of all, two questions. First question would be, over the years, do you have any situations where extensions became either made redundant by new functionality introduced by Postgres, or perhaps absorbed somehow? Has that happened before, where suddenly an extension was no longer relevant because Postgres introduced native functionality? And the second question would be something that happened late last year, where Postgres had to release, or anyway, they had a out-of-cycle release because they had broken timescale DB. And I'm just wondering if that's something that happens frequently, or was maybe the first time this happened, and if the fault was on timescale DB doing something they shouldn't have, or Postgres broke something unintentionally. I wasn't too sure of the situation, but for me, that was like the first time I encountered this situation. I was just curious if something happens frequently. Thank you.
Thanks. Yeah, so the first question of like, are extensions sometimes made obsolete by new Postgres features? It mostly happens to extensions that are specifically built with that purpose. So there's been an extension, I mean, it still exists, called PG failover slots, which was sort of a segue into adding support for logical replication slots that survive failover to a physical replica. So there's an extension for that, but it's now also in Postgres. So if you use the older versions of Postgres, you can still use the extension, but in the newer ones, it's obsolete. And there's extensions that are sort of maybe meant to follow that path. And I'm also always sometimes wondering, is like, why don't we actually just put PGCron into Postgres? It's like everyone needs a job scheduler apparently, so maybe we should do that. I think PGIVM, for example, is very much built to maybe one day be integrated into Postgres as a feature. It doesn't happen a lot, but like mostly the extensions that are specifically built for that purpose of trying something out. And there's also like been PG logical and that's become logical replication. There's still some things that PG logical does, but most of it, of its original goal, is now obsolete. So for the second question, so yeah, last year there was like a sort of ABI breakage, the sort of binary interface changed. And it sort of comes back to extensions are patches. And they, when, I think what happened is like one of the structs in a header file changed its size, or there was another field added, which extensions are often built against Postgres, let's say 17.1, but then you install Postgres 17.2 and the extensions still work. I mean, some platforms, they just recompile all the extensions for every patch release, then you usually don't have a problem. But if you expect an extension compiled against 17.1 to still work on 17.2, like most of the time that's true, but if, for example, a struct changes size, then it may no longer be true. And a lot of the time, maybe it happens more often than we think, but there's only a few extensions that touch really deeply in these internals. We have seen it in the past in Citus that we needed to rebuild for a new patch release. Timescale kind of got hit by it last year, and there's always like, is it Postgres' fault or is it Timescale DB's fault? Like, these rules are not very strictly written. Like, who's responsible for, like, is Postgres supposed to always keep structs the same size? Well, they kind of want to, but it's also sort of best effort. But it's fortunately, it's quite a rare event that is hit someone. But of course, the extension ecosystem is growing. There's perhaps some likelihood that it'll start happening more in the future as also extensions start going more deeply into the cookie jar and trying more things. So yeah, there's some discussions on like, okay, what parts can we rely on and what parts can we not? Like, what's the contract? I mean, so far it's just not very well defined, and it's more like, okay, well, it doesn't happen so often, so let's ignore it. But yeah, it's definitely a topic of active discussion.
More questions? Okay.
Real quick, what's the worst exploit you've seen that is good for extensions? Yeah, I think this one has been pretty common. We've seen this at Microsoft. We often got reports from Wiz, like the security company that just makes it their main job to find these types of exploits, and then they sort of say, "Hey, here's this thing we're going to publish, and you can pay us a little bit of money if, if you want to wait us to wait or something." And we started poking around, and we realized actually other managed services have similar vulnerabilities in a lot of commonly used extensions, even like PostGS, pgpartman, some of the really popular ones, PGCron for sure, Citus as well. For Citus it was more the other SQL issue, but yeah, these kind of SQL vulnerabilities, they're of course very serious because sometimes you think, oh well, my users are there's just one application. It's a sort of I trust my developers, but the thing is they could make a mistake and have a SQL injection vulnerability, and so now your user is not who you think is your user. And attackers also just have a lot of time. They don't mind planting a seed and waiting for a few months for someone to upgrade Postgres and then run all the update scripts and then have if they know there's a vulnerability in an update script. So yeah, I mean, security issues are always kind of the most serious. Fortunately, there's nowadays very good security researchers that find these before attackers do. Although you also don't always realize attacks happen because attackers like to keep quiet. But that's yeah, I think that's the biggest one to watch out for.
We'll take 2 more questions.
I have maybe a simple question that when you install a create extension, it's for the database, but it's associated with the schema. And you cannot, if the schema is not in the path, searching path, that extension is not working. So if it's only can install once for the dataset, for the database, why is it associated with the database? And any schema just can use it instead of make this logic sometimes very confusing.
Yeah, so I hold the sometimes controversial view that extension schemas are an anti-feature that should never be used. But I mean, the problem it's trying to address in part is that for functions, okay, it's sort of intuitive. Okay, so it's instead of in a table, I do ext.in a table. For operators like equals, it's a lot less intuitive. How do you qualify an operator? I can barely remember myself. You actually have to write operator, parentheses open, schema name, dot, and then equals, parentheses close. That's how you schema qualify an operator. So if you create operators, it's nice if they're in the search path. By letting the user pick a schema, they can sort of put the extension in the public schema, for example, which is usually in the search path. In a way, it's a problem that needs to be more rigorously solved. Of can an extension create stuff that's just have some control over the search path, for example, or have a sort of magic search path where we can plug our operators into. It's not obvious to me what the alternative to extension schemas is. When I can avoid them, I avoid them.
Hello. My question might be also a bit basic. My question is when you upgrade Postgres, that's the recommended safest way to deal with your extensions? Should you drop all the extensions before you upgrade? And after you upgrade to a major version, you recreate your extensions? Or you try to run the update? What do you recommend? If your extensions don't keep a lot of state in the database, let's say that.
Thanks. Yeah, unfortunately, the answer is it depends on the extension. But for the most part, extensions survive PG upgrade. It'd be nice if there was a little bit more test infrastructure anywhere for testing extensions with PG upgrade. We've had to sort of build that ourselves a few times. It's not a given that if your extension keeps state that it actually survives the PG upgrade. With OIDs, sort of goes wrong. Yeah, you definitely don't want to drop those extensions before the PG upgrade. So, I mean, most managed service platforms, like in general, they will keep the extensions across upgrades. If there are certain extensions that have specific requirements, they just need to code against all of those. Like managed services then they're generally a little bit messy. Like the upgrade process can be quite messy. There's also like certain types of tables. If you create them, PG upgrade no longer works. Or certain views on extensions that if you create them, PG upgrade no longer works. So it's a little bit of a messy process. As a sort of general, drop all the extensions, recreate them, I probably wouldn't go that route, like just sort of, except for specific extensions that prefer to be upgraded that way. But like, properly tested extensions, they will generally survive PG upgrade. One sort of minor thing, like, you have to be a little bit careful about PG upgrade is sort of running a little Postgres inside, and it will load shared preload libraries unless your extension is also explicitly careful about not getting loaded during PG upgrade, because weird things can happen if that's the case.
The last question.
Hi, my question is around, is there any guidelines on contributing to extensions, like how Postgres has a set of guidelines, or is each one independent on its own with their own ecosystem? Second question.